Have you ever been talking on the phone when all of a sudden the signal drops? We constantly rely on cell signal in order to communicate with each other over phone, and our neurons rely on a different type of signal to communicate with each other. So what's the cell provider that's keeping our neurons in sync? Those are glial cells, specifically star-shaped cells called astrocytes, and that's what we're going to be talking about today.
Neurons communicate at tiny gaps called synapses. The first neuron releases a chemical message, often glutamate, and the next neuron has receptors that detect it, like a speaker receiving sound. But here's the problem. Chemical messages don't auto-delete. If glutamate lingers, the signal turns from a regular message to an overload. Imagine if every text you ever received stayed on your lock screen forever, stacking on top of each other until you couldn't see the new one. Astrocytes prevent that at synapses. They use high-powered glutamate transporters, especially EAAT2, to vacuum up extra glutamate right after the signal is sent. That matters because too much glutamate for too long can push neurons into excitotoxicity, basically overstimulation that then damages the cells. Next, job number 2, stopping interference when traffic spikes. Every time neurons fire, they change the ionic environment around them, especially potassium levels. If too much potassium builds up outside neurons, neurons become too easy to trigger. That's like a cell tower getting so overloaded that random calls start connecting when no one even dialed in the first place. Astrocytes then act like surge protectors. They pull in extra potassium and distribute it through their network, a classic idea called spatial buffering. Moving on to job number 3. Astrocytes send power to the busiest areas. Neurons are incredibly energy expensive, and when one brain region gets really busy, it needs more fuel and more oxygen. Astrocytes have end feet that wrap around blood vessels, putting them in a good position to help link neural activity to local blood flow. This is called neurovascular coupling. So in the network analogy, astrocytes are not just deleting text and preventing interference, but they're also helping to route extra power to the places that are doing the most work. Now here's the twist. The network itself can also tune the conversation. For a long time, astrocytes were treated like passive support, but now we know that they respond to neuronal activity with internal calcium signals. And in some contexts, astrocytes can release signaling molecules like ATP or D-serine that can influence how strongly synapses transmit and change over time. Scientists are still debating exactly when, where, and how dominant this gliotransmission is, but it's strong evidence that astrocytes can be active partners in information processing, not just background staff. And that's the core idea between the tripartite synapse. One neuron sends, one receives, and an astrocyte manages and tunes the space between them. Astrocytes make sure that the conversations that keep your brain running continue coming through, making them essential helper cells and not just filling up space in the brain. Astrocytes truly are the star of the show.